Okay, in this lesson I want to look at just a bit of revision of some junior cert theorems. A couple of different things I'll mention just to know. Here's three objects on the screen. This top one is a line. Lines extend infinitely in both directions. They have no end points. This one is a ray. A ray extends infinitely in one direction, but it has one end point. And this is a line segment. This has two endpoints. It does not extend infinitely in either direction. Okay, so a line, a ray, and a line segment. Three different things. You should know what they look like. I want to talk a little bit about transversal lines. So a transversal is a line that passes through two other lines in the same plane. So a plane is a flat surface. This screen I'm working on at the moment is a plane. You can think of the floor as being a plane. Okay, it's just a flat surface. Interior plane extends infinitely in all directions. So I'm going to look at transversals. And when we draw a transversal, this blue line here is my transversal across these other two lines. When we draw a transversal, there are 8 angles created. I'm just numbering them here so I can describe them. Okay, there are 8 angles created in two little bunches. You know, there's a little bunch of angles up there. There's a little bunch of angles down there. So we have two little bunches of angles. 8 angles created in two little bunches. In between the two lines that are being crossed is called the interior. Outside of them is called the exterior. So the exterior angles here, if I look at the exterior angles in this particular setup, the exterior angles are angle 1, angle 2, angle 3, angle 7, and angle 8. Okay, they're the exterior angles. The interior angles are in the interior, 3 and 4 and 5 and 6. Angle 3, angle 4, angle 5, angle 6. Notice when I'm writing angles, I put my angle symbol in front of it. So interior angles and exterior angles. You got to know which are which. The other thing we need to talk about is how to describe pairs of angles. And there's lots of different ways to describe pairs of angles. And the language is very important here. The language is very important, so you need to use the correct language all the time when you're describing pairs of angles. Again, I'm just going to number these 8 angles that are formed so that I can describe them properly. And I'm going to talk about pairs of corresponding angles first of all. And corresponding angles are angles that are in the same relative position in the separate bunches. So this angle up here, for example, this 1, that's in the same relative position as angle 5. So we'd say angle 1 and angle 5 are a pair of corresponding angles here when this transversal crosses these two lines. Take another pair of angles. Yeah, angle 3, that angle there, that corresponds to the position of 7 on the bottom kind of bunch. So we'd say angle 3 and angle 7. They're a pair of corresponding angles. Up here, the top right in each, they're corresponding angles, angle 2 and angle 6. And then finally we've got this angle in here, that angle 4 in the same relative position as angle 8. There's another pair of corresponding angles. So corresponding angles, they occur in pairs, and there's different ways to pair angles. Okay, you need to be able to identify pairs of corresponding angles when two lines are crossed by a transversal. Vertically opposite angles, well, vertically opposite angles occur when two lines intersect, and vertically opposite angles are just kind of opposite each other. They share a vertex, but they do not share a side. Okay, so that angle there and that angle there would be vertically opposite angles. So in here, my pairs of vertically opposite angles, well, my first pair of vertically opposite angles would be angle 1 and angle 4. But we also have angle 3 here and angle 2. And we also have angle 5 and angle 8. And then we also have angle 7 and angle 6. Okay, there's another pair of vertically opposite angles. Okay, so ways of pairing angles, and there's lots of different ways to pair angles. I'm going to be looking at other ways to pair angles. So, and you have to know the correct words to describe the pairs of angles. Here we have same side angles. Again, let me just number my angles. 1, 2, 3, 4, 5, 6, 7, 8. Same side angles can be broken up again into two kind of groups, the same side interior angles and the same side exterior. These are sometimes called co-interior and these are called co-exterior. So same side interior angles, they're in the interior and they're on the same side of the transversal, and one has to be from each group. So 3 and 5 are a pair of same side interior angles. So 3 and 5, angle 3 and angle 5, they're a pair of same side interior angles. Angle 4 and angle 6, they're a pair of same side interior angles. Okay, the same side exterior angles are just they're on the same side of the transversal and they're in the exterior. So angle 1 and angle 7 in the same side of the transversal and they're in the exterior. They're a pair of same side exterior angles. And finally, angle 8 here and angle 2, they're on the same side of the transversal. Remember, the transversal is this blue line. Angle 8 and angle 2, they're a pair of same side exterior. These are also often called co-exterior angles and co-interior angles. And there are theorems that relate to those things as well. Okay, so that's same side angles. Alternating angles can be broke up into two kind of separate groups as well. The alternate interior and the alternate exterior. Okay, and they are angles that are on opposite sides of the transversal. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 angles occur when a transversal crosses two other lines. 8 angles occur in two separate bunches. The alternate interior angles, well, they're going to be one angle from each bunch. They're going to be on opposite sides of the transversal, and they're going to be in the interior. So angle 5 and angle 4, they're on opposite sides of the transversal, and they're in the interior. Angle 6 and angle 3, angle 6 and angle 3, they are on opposite sides of the transversal and in the interior. Angle 1 and angle 8, well, they're a pair of alternate exterior angles because they're in the exterior and they're on opposite sides of the transversal. Okay, and one from each bunch. We have to have one from each bunch. They can't be in the same bunch. And then finally here we've got angle 7 and angle 2. Okay, so there is alternate interior and alternate exterior angles. A couple of important definitions. Two angles are said to be supplementary. You'll be hearing that word used if and only if their measures add to 180. So, you know, a 45-degree angle and a 135-degree angle are two angles that are supplementary because their measures add to 180. A linear pair of angles are formed when a ray with its endpoint on a given line is drawn. So if I draw a line and I draw a ray whose endpoint is on that line, let's draw a ray. What I have here is a linear pair of angles. So this angle here and this angle here are a linear pair. Notice all linear pairs are supplementary because together they make a straight angle. So if that's A and that's B, well, you can see angle A and angle B add up to 180 degrees. So again, a huge part of geometry is about the language. Make sure you know what supplementary angles are. Make sure you know what a linear pair of angles are. They form a straight angle. Three important theorems we're going to look at. Theorem 1 from junior cert said vertically opposite angles are equal in measure. Theorem 1, vertically opposite angles are equal in measure. So if I draw a pair of lines, that angle is going to be equal in measure to that. Also, this angle is going to be equal to that. Okay, and there's a proof that's very simple. I'm not going to go through the proofs in this class, but there is proof. Two lines are parallel if and only if their pairs of alternating angles are equal. So if I have two lines and I draw a transversal, if the pairs of alternating angles are equal, well, that means the two lines are parallel. Theorem 5 says two lines are parallel if and only if their pairs of corresponding angles are equal when I draw some transversal. So in other words, if this angle is equal to that angle, then these two lines have to be parallel. Okay? And two lines are parallel if and only if their pairs of same side angles are supplementary. So once again, I've got two lines. If I draw a transversal and I take that as A, and if I take that as B, well, if A and B add up to 180, well, then the two lines are parallel. Okay? And notice the converse of these, each of these are also true. Okay, so if their pairs of alternating angles are equal, they are parallel, and also if they're parallel, then their pairs of alternating angles are equal. So I'm going to have a look at a few problems based around those four little theorems. Fill in all values for all missing angles. Well, this is the vertically opposite angles theorem. That 45 is opposite this one. That has to be 45 degrees. Note together, these two angles form a linear pair, which means this has to be 180 minus 45, which would be 135 degrees. And again, that's my vertically opposite angle. Pairs of vertically opposite angles are equal. That has to be 135 degrees. Really straightforward. Two lines parallel if and only if their pairs of alternating angles are equal. This is theorem number 3. Okay, so for example, if this is 30, its alternating angle. Notice it's telling us the angles are parallel. That's what these little arrows mean. We're looking for, we know the two lines are parallel if and only if their pairs of alternating angles are equal. So if they're parallel, we can conclude that their pairs of alternating angles are equal. Alternating angles are on opposite sides of the transversal. This is an interior angle, so the alternate interior angle to that will be equal to it. So that's 30 degrees. This is an alternate exterior angle. We're given the lines are parallel. That means the alternate exterior angle over here, 60 degrees, is the alternate exterior angle to this. They're on opposite sides of the transversal, one from each bunch, and they're in the exterior. Okay, so that's using theorem 3. Theorem 5, two lines are parallel if and only if their pairs of corresponding angles are equal. Notice these lines were given are parallel, so we conclude that their pairs of corresponding angles are equal here. So in this bunch, this is 30. This is the corresponding angle from this bunch, and that has to be equal because we know that two lines are parallel if and only if pairs of corresponding angles are equal. Similarly, over here, we're given two parallel lines. We know that two lines are parallel if and only if, for some transversal, their pairs of corresponding angles are equal. So if these are parallel, then we can conclude that the corresponding angle here is also 60 degrees. Two lines are parallel if and only if their pairs of same side angles are supplementary. So here we're in the interior. We're given the lines are parallel. This is an interior angle 30. Together with its same side interior angle, this one, they are supplementary. Remember, supplementary means adds to 180 degrees. So that means that has to be 150 degrees. Same side, interior angles, supplementary. Here, two lines are parallel, so their same side angles are supplementary. This and this are a pair of same side exterior angles. If this is 60, this has to be 120 because together they have to make 180 degrees. Okay, these are all junior cert theorems. Theorem 3 says two lines are parallel if and only if their pairs of alternating angles are equal. Prove that the lines A and B are parallel here. So I'm given that these two angles are 60 degrees. So I'm going to say A is parallel to B since their pairs of alternating interior angles are equal. Alternating interior angles are equal in measure. Instead of writing the word equal in measure there, I could have written the word congruent, which means identical. So congruent means identical. So you can write equal in measure there, or you can write congruent. Okay, A is parallel to B since their pairs of alternate interior angles are equal in measure. Prove that the lines A and B are not parallel. Well, look, we have a pair of angles here, and this is my corresponding angles. These are corresponding angles, however, they are not equal. Okay, so A is not parallel to B since their pairs of corresponding angles are not equal or congruent. They look like they might be parallel, but on closer inspection, that's 60, that's 62. No, they're not parallel. Okay, eventually, if those lines go on further and further, they'll eventually come together. Not parallel. Parallel lines will never come together. Prove lines A and B are parallel. Okay, again, why are they parallel? Well, we can see they're parallel. Why? Because they are parallel if their same side angles are supplementary. Remember, supplementary means they add up to 180 degrees. So I'm going to say A and B, or sorry, A is parallel to B since their pairs of same side, in this case interior angles, are supplementary. Notice they're not congruent, they're not equal, they're supplementary. That's 30, that's 150, together they add to 180. That means those two lines are parallel. Okay, so we got to know those theorems inside out. Here's a parallelogram. I know it's a parallelogram because of the arrows telling me this side is parallel to this, and I want to fill in all the different parts of the parallelogram. I'm going to use this theorem, which says two lines are parallel if and only if their pairs of same side angles are supplementary. So if I take this line segment here, which is just part of a bigger line, and this line segment, you know, we can think of this side as being a transversal to those two sides, which means their pairs of same side interior angles are supplementary, which means this has to add to this to give me 180 degrees, so that has to be 110 degrees. The pairs of same side interior angles are supplementary. If I think about this side and this being a pair of parallel sides, with this top side being the transversal. Well, then this angle and this angle would be the same side interior angles, and they are supplementary. That would have to be 70 degrees. Okay, I can think of the top line and the bottom line as being a pair of lines, with this side here as the transversal, which means the pairs of same side interior angles are supplementary. If that's 70, that's 110 degrees. Notice in a parallelogram, a result of this is two things. First of all, consecutive angles are supplementary. And second of all, opposite angles are equal. So consecutive angles means as you move around anti-clockwise from one angle to the next, you get pairs of supplementary angles, 70 and 110, 110 and 70, 70 and 110, 110 and 70. Opposite angles, those two are equal. Opposite angles, those two are equal. Okay? So there's 4 theorems from junior cert you have to know. It's fairly basic. Make sure particularly you know all the language, and practice, practice, practice.